Hi and welcome to our Strategic Facility Planning for OKKO 2.0. We are Group 2 and these are our members.
Hello everyone, I am Solale. This presentation outlines the overall layout design for OKKO, a new manufacturing facility located at the Barnside Industrial Park in Dartmouth, Nova Scotia. The goal of this project is to design an efficient and integrated layout that boosts productivity and supports long-term growth. The factory will manufacture 10 different products using flexible processing stations supported by an optimized warehousing system and a strategically placed office and employees area. Key layout components include production layout, office layout, warehouse layout, and parking layout. We also consider the important factors like safety, and accessibility, cost efficiency, and space optimization. All of these are planned to meet the project's constraints and operational goals. In this part of the project, we estimate the machine requirements for OKKO's new plant using the group production line method. The main productive is to determine how many machines are needed per shift for each production line, while also comparing this approach to alternative methods, especially in terms of machine utilization, cost, and operational flexibility. This formula helps us how many machines we need based on time, reliability, and demand. Here is our production lines. The production line 1 handles product 1 with a daily demand of 250 units. The production line 2 handles product 2 with a daily demand of 400 units. And production line 3 handles product 3 to 10 with demand ranging from 10 to 25 units per day. Grouping similar products helps us improve scheduling, reduce setup time, and optimize machine use. In this section, we show the machine requirements for each production line, broken down by machine type from A to J. The table summarizes how many machines are allocated per type and per line. The line 1 requires 20 machines in total. The line 2 needs 33 machines and the line 3 uses 15 machines. That gives us a total of 68 machines across all production lines. In conclusion, using the grouped production line method allowed us to maximize machine utilization, improve operational flexibility, reduce capital investment, and simplifying maintenance and production planning. These methods grouped products based on similarities in their production process and demand levels, resulting in better allocation of machines and a more cost-efficient layout. When compared to other methods, this approach proves especially effective in setups involving multiple products and varying daily demands.
So moving on to the production layout, based on the flow analysis, the flow dominance was calculated to be 0.2, indicating that there are no dominant flows between departments. This made it necessary to use both quantitative and qualitative methods when determining the layout, resulting in a process or product family layout being the most appropriate choice. The plant features 3 production lines. We have production line 1, which handles product 1, and production line 2 handles product 2, and production line 3 handles products from 3 to 10. An S-shaped flow pattern is followed between machines to ensure smooth movement of materials and to also reduce congestion. A raw material line is positioned before each production line. An assembly line is positioned after the final machines to complete product assembly. Automation has been taken into account. Machines are expected to run or operate automatically with minimal manual operation. A handling factor of 1 has been applied throughout to reflect consistent effort in the material handling. So as you can see on the slide displays the machine layout, both with and without the dimension to illustrate or show the flow and the space allocation.
The material flow at OKKO follows 6 key stages: receiving, quality check, raw material storage, machining, final inspection, and finished goods storage. This flow is designed to minimizing backtracking and create a logical U-shaped layout. Forklifts handle intercell movements with 1,580 moves per day, requiring 3 forklifts. Manual handling covers 4,875 move daily, needing 15 handlers. Our aisle design includes two-way aisles, 20 feet wide for main roads, and one-way aisle, 10 feet for secondary path. This configuration used 28.3% of the facility footprint. Safety measures include anti-fatigue mats, emergency stop button every 15 meters, and clear marketing for pedestrian and forklift lanes, ensuring compliance with OSHA standards. We have allocated 24 staff for material handling, including 9 forklift operators and 15 manual handlers, spread across 3 shifts. Our supported space include 18 square meters for lockers, 36 square meters for break areas, and 6 square meters for washrooms, all within ergonomic guidelines. The result is an efficient layout, a reduced idle time, and safe working environments.
Hi, I'll be talking about our warehouse design. To start off with, a warehouse for a production facility plays a crucial role in ensuring there's a smooth flow of raw materials, components, and finished goods throughout the whole production process. For our design of the warehouse, we decided to go with two separate areas for the finished goods and raw materials. The reason we decided to go with two separate areas was to improve organization and inventory control and also help with the quality control. We decided to also have some safety stock for each product aside from the daily demand. And also, we went with having different pallet sizes for our finished and raw goods based on their different box sizes. And after our calculations, we have a raw material storage with a dimension of 100 feet in length and 200 feet in width. And for our finished goods, we have 50 feet in length and 100 feet in width. And to accommodate for the movement of materials at each storage space, we have 3 docks in our raw material storage and 2 docks in our finished goods storage. And now to talk about our parking layout, we designed it to accommodate 128 standard size cars that fit based on a double loaded wall to wall continuous curb design. It is a two-way parking design where the driveway width is 32 feet. And based on our calculations, we have a parking lot design which is 136 feet in length and 264 feet in width. For our calculations about why we chose 90 degrees and which was our optimal answer, you can refer to our project report.
Okay, so this part covers the office layout, which is divided into two areas, which are the outside offices and the inside offices. The outside office is 19,200 square feet and includes departments such as administration, IT, purchasing, marketing, accounting, and human resource, along with break room slash cafeteria, locker room, and washrooms. As you can see on the slide, it was designed using the core lab method to place departments that work closely next to each other. The inside office covers 6,000 square feet and includes the engineering and production control departments. These are placed close to the production area. The space also includes storage, printing stations, and meeting rooms. Innovative design features include smart glass partition that can turn private when needed, and also ergonomic workspaces and natural lighting to promote employee well-being. And additionally, washrooms in both office zones include accessible facilities to accommodate all the staff.
So the safety features of our plant. So it'll be equipped with a sprinkler system throughout the whole building, fire alarm system throughout the whole building, emergency exits where needed, fire extinguishers as well throughout the whole building. Eye wash stations will only be in the production area, as that is where they will most likely be needed, and AEDs will be throughout the whole plant. All of these will be in accordance with Nova Scotia's building code guidelines and fire safety guidelines. So this is the cost analysis for the building. So starting off, we have the production cost. So the production cost is $7,669,190. This cost includes the machine purchase, machine operation, and then any cost for the forklift. So that includes insurance, fixed costs, maintenance costs, and fuel costs. These costs are based on the quantity and the frequency, as you can see here. Everything is mostly yearly, except machine purchase is every 7 years, and then obviously maintenance costs and fuel costs is every 32 days to 500 kilometers, or 5 days for the fuel. So this is based on the distance it travels, how often it travels, and vice versa. The building costs, you can see here, we start with the miscellaneous, so that's the bay doors, fire alarm system, and sprinkler system. Those are based on quantity plus the square footage, so that's how they got those costs. The outside office, inside office, raw goods, finished goods, area, machine, and then any of the extra building space when we combine it all together. That is based on square footage that we got through our Visio and Core Lab calculations, and then just multiplied by the total cost of steel, mechanical, electrical, exterior cladding, all of those costs. And then we have the land of building. So this is just the cost of all of the land to build on. So that would include roadways, the whole plant itself, and then the parking. So that is 302,400 square foot, which would give us the 1.8 million. Then we have the employee costs. So that is based on our 3 shifts, all of the employees we have, as well as salaries. So all salaries that were given, we used. Any other salaries that weren't given, we used based on the Nova Scotia Job Bank average salary. So that would be a daily salary of $49,925 for all of our employees. So in conclusion, this is what our plant looks like. So as you can see, we have combined all of the productions together, and we've also added a roadway around for the trucks and the employees to get around, just to make sure that it's clear on how they can go. Then we have our 3D models. So this right here is what the production floor will look like. This is how all the machines, so here's one production line, and then this big one is the 3rd production line. In the bottom right, you can see the total plant of the 3D without the roof and no doors. So here we have one of our storage areas, another one of our storage areas, the machine area here. This is the inside office in the plant, and then this is the outside office. And then the parking lot will just be right here. So these are all the references that we use to get any of our data, or if we needed to cite anything. So these were the references that we used. Thank you for watching and your time.